Alright, so like I said, on Friday we focused a lot on working on the implicits. So something like number 1, it asks you to find the derivative for the circle. So you have an x squared, you take your derivative, and then you're evaluating the derivative at a point. So what that does is that dy dx at the point 3, negative 4, that represents the slope of this figure at that point. So again, that represents the slope of the circle at this point. And then in number 4, going just across instead of in order of the problems, we took our derivative and then they only gave us y equals 1. So the only way to find x was to plug y equals 1 in and solve for x. So you had to take that 1, plug it in here, here, and here. And then you had 2x plus x equals 1, and you had to go backwards and solve for x, getting you that x equals 1/3, which you could then plug in and then utilize with your dy dx's. So a lot of what we do in implicit is really focusing on substituting. A lot of what we're doing is substituting from one part to the next to get us down to that answer we're looking for. Again, if 10 was difficult for you, don't worry about it. But back to like the handout. So number 14 is a lot like the problems that we did on Friday, where we had the pi x inside our trig function. And you have to remember that when you take the derivative of sine pi x or cosine pi x, to make sure you take the derivative of pi x and bring that pi out. So that same problem we saw, on Friday in that trig derivative review is also popping up here on our circuit review. It was also on our tests from like a week or 2 ago. So just be careful. That pi x inside a trig function happens often, and you just have to remember to leave the pi out. Like, make sure you get that pi. Okay, number 3 and number 8. I feel like number 3 is pretty easy. Again, rate of change is just another word for derivative. Make sure when you take sine y, you put dy dx because it's a y variable, not an x. Over here, number 8, you make sure you use your product rule. So first times 2 to the second plus the second times 2 to the first. Seven and 11. I think 11 was tricky just because of the exponents. I'm going to give you guys like a few more minutes to check that one. And again, if I'm going through these and it's too quickly, just let me know. We can go back. Okay, 12 and 2. Five and 15. Okay. So for number 9, again, you have your chain rule where you have to take the derivative of the outside. So you're taking that 1/2 x plus y to the negative 1/2, then taking the derivative of the inside. So when you do that, again, you just have to be really careful to understand that the 1/2 square root x to the negative 1/2, x plus y to the negative 1/2 distributes to both the 1 and the dy dx. And that's why our answer down at the end sort of filters out a little differently. Okay, and then in number 16, it asks you to find the slope of the tangent to the ellipse at a point 4, 0. So again, you're plugging in 4 for x, 0 for y, and solving for dy dx because dy dx represents your slope. What happens is we end up getting a zeroed out dy dx because of the 0 on the y connected to the dy dx and or the 0 over here. So what that means is that the derivative is undefined at that point. And that should make sense to us because this is an ellipse and the point 4, 0 on that ellipse would be at, see, this is why I don't like Teams. I don't know how to draw right now. Like I can't draw on this. I want to write so badly and I cannot. So basically what's happening is you are over here at the end point of the ellipse, so you have a vertical tangent with your slope, which is why your slope is undefined, because you get a number divided by 0. We can't divide a number by 0. That makes our slope undefined because it's at the end point of the ellipse. Okay, 13 and 6. Okay. So again, are there any questions on any of those problems? Anything you want to see worked out more? I can always go to a document camera to kind of do that. Okay, so go ahead and find the derivative of that. You have tons of time. And select your answer. And then we'll talk about our answers after. So find the derivative of y squared equals 10x. Awesome. All right. So fantastic, guys. We did 5 out of 5. Everybody got 5 over y. Excellent.
Be careful, it says second derivative. Again, just be careful, second derivative.
What does the colon x over y mean?
I don't know. I think like I might have, I have two thoughts, and one is a hint, and the other is I originally had this set as two questions where the first one was to find the first derivative, and then the second one was to find the second derivative, but I like knew I deleted one and couldn't fix it, and I gave up because Quizzes was being stinky. So we're going to go with that it's a hint.
Okay, so let's go over this problem. So if x squared minus y squared equals 25. So let me go to teams. I go to this. I think I can hide, share, and then do a whiteboard. I'm going to have to type this though, because this is on my laptop now instead of my on my iPad because we got kicked out. So if you have x squared minus y squared equals 25, your first derivative becomes 2x minus 2y dy dx equals 0. And then this is why I said that one was a hint, because you had negative 2y dy dx equals negative 2x, and then you got dy dx equals negative 2x over 2y, which became x over y. So that's why I said, I was like, I'm pretty sure originally I wanted you to do dy dx and then find the second derivative. So now, as we look at our second derivative, we already have dy dx, so it becomes d2y dx squared equals, and then you're going to take the derivative using the quotient rule of x over y. So that gives you ho d high minus high d ho, and the derivative of dy dx. I don't know how to make my font smaller on Microsoft Whiteboard.
I don't know if anyone else can, but I cannot see the screen.
Good. All right, let me. Can you see me typing on the whiteboard? So can you see what I'm typing on the whiteboard? All over the derivative of the denominator squared, so you get your y squared. So this is where I think we start to run into our issues, because the dy dx is y minus x, and then you have to go back and substitute in x over y, because that is what dy dx is originally. So you have that y minus x times x over y now still all over y squared. And then as you simplify and clean this up, we get y, but it needs that denominator of y so that they can be like terms. So it ends up becoming y squared minus x squared all over y cubed. Because again, initially you have your y squared. This creates a denominator of y. So if you were to have your y minus x squared over y all over y squared, these two need a common denominator. So you have to multiply by y over y, giving you this y squared minus x squared all over y cubed. And then if you go back to your original problem, it's x squared minus y squared equals 25. So you can flip those terms around. So you get y squared minus x squared equals negative 25. So basically all I did was divide everything by a negative, but that allows you to substitute x squared minus y squared with a negative 25 all over y cubed.
That's a dirty trick, Mrs. McBride.
I don't know what you're talking about. I think it's quite nice. So those are the types of problems that when you're taking a multiple choice test, I think make it the most difficult, because you have to really know how to get down to that simplified answer. So maybe a little bit
Chase just messaged us privately asking to be let into the meeting.
Okay. He's gonna have trouble now though, because he can't do the quizzes with us, I don't think. Ooh, look at that close leaderboard. Good job, guys. All right, fantastic. So again, big difference from last one to this one was the negative. So again, you got a negative on the x squared this time. Good job, guys. All right, so again, we are finding these implicit derivatives and then rearranging the terms to solve for dy dx. Okay. So how do we do? All right, fantastic, guys. I am loving these 5 out of 5s. Again, just solving for that dy dx, making sure we clean up our terms and watch our signs. Okay, so again, my hint, x times y is a product. X times y is a product. Okay. Awesome. So for this one, anytime you have a product rule, it's going to really expand the number of terms you have because it's going to put you in a position where you have first times root of the second plus second times root of the first. And in this case, our first and seconds had a lot to do with the number 1. So you ended up with that 2x plus x dy dx plus y plus 3y squared dy dx equals 0. And then you had to keep the x plus 3y squared on the left and the negative 2x plus y on the right. Okay, so again, if you were here on Friday, this should be easy for you. really hinted at these types of problems. Holy moly, close game. Fantastic. 5 out of 5. All right, guys, you're doing fantastic. I'm so happy. Okay, so again, you're finding the equation for a tangent line. Yeah. Okay, it might be because you were so late to the class that it started and they won't let you in late. There's not much I can do. We still have 4 questions left. You can kind of work along and do them on paper, but you won't be able to get into the game. You'll have to do the game later. So doing them now is at a disadvantage. Awesome. Are you guys all secretly texting each other so I don't know when you're sharing answers? You guys went from... Okay. So again, just be really careful for this one because the difference between the correct and the incorrect answer was simply the negative. Remember that when you move over your product rule, you subtract it to the other side. So did you two realize that it was the same problem from the previous slide and all you had to do is plug in your numbers? We'll disable timer. Okay, good job.
Alright guys, so maybe let's go over this question because it looks like we had some troubles. Cosine x plus 3y equals tan x, x tan y. Alright, awesome job, you three. So you guys are getting participation points again for today's live group session, just like I did on Friday. Alright, so again, the big things you guys have is you are going to utilize the rest of class time today. You can get a jump start on the winter break packet. So that's going to be uploaded here, and I'm going to send it in the group chat. And then you can also take your AP Classroom 3.7 Implicit quiz at any time. It is now available. It became live at 9 a.m. today. Any questions for me on any of that?